Let's go to the next problem. Problem 8. A random sample of freshman students' combined SAT scores were collected at a competitive university. The data is shown below. Construct a confidence interval about the population mean SAT scores of freshman students at this university. So here's the data, 1210, 1360, 1250, etc., etc. What this means is we are given sample data for this problem. First, we have to determine the sample mean and the sample standard deviation. Once we get those two things, this problem becomes just like all the other ones that we've done so far as it pertains to finding the confidence interval about the mean. Hopefully by now you know the formula to get the mean average. Basically, all we do is add up all the data values that we're given and we divide by 11. We'll do this on a spreadsheet and we'll do it even more easily than that because we'll just type in the numbers and use the equals average function. And we'll also get the standard deviation of a sample, so the stdev.s function, just like we did on the way earlier spreadsheets that we did. And I'll tell you now, we get s equals 104.194. Again, we're going to pop this all on a spreadsheet. I'm just sketching out the problem here. The correct sampling distribution is the t distribution because, again, we're not given sigma. We're going to end up with a sample standard deviation, but that's s. We have x bar, and that we had to calculate, but it was 1321.818. My s was 104.194. N equals 11, so new is 11 minus 1, which equals 10. And my level of confidence, hey, that was not given in the problem, so we use the default of 95% level of confidence, which means alpha equals 0.05, and alpha over 2 is 0.025. T sub alpha over 2, remember the old t.inv.2t function, and that would be 0.05 comma 10 degrees of freedom, and that gives us this number here. And the E calculation is we take the t sub alpha over 2 times s over the square root of n, and that gives me approximately 70. What that means is the confidence interval is whatever my mean is minus 70, whatever my sample mean is plus 70, and it works out to be 1251.8 is less than mu, which is less than 1391.8. In other words, we can be 95% confident that the true population mean of the freshman class at this competitive university, that their combined SAT scores fall somewhere between 1251.8 and 1391.8. And that's basically what the conclusion is right over here. Let's go to a spreadsheet. Here I have a spreadsheet that's set up especially for this particular type of problem. I listed my data here, 1210, 1360, 1250, and so on. And you can check in the problem to make sure that that's all right. We have x bar equals, and well, x bar is the sample average, which equals AVER average. And I'm going to grab the first one and go down to the bottom one and close my parenthesis. Now make sure that when you're doing this problem, you if you have data, maybe you only have 6 data values. So make sure that you retype the whole formula for x bar over here equals average, and then drag and capture only the numbers that are for that problem. And if it has to go further than that, well then, make sure that you grab much further in the function. We have s equals, and well, that's the sample standard deviation, equals stdev dot s. And again, I'm going to drag all of that, or capture all of that, close, and press enter. Now, there's a number of ways you can get n. You can get it from, you could develop a formula to actually count those, but I'm not going to give you one that has a whole bunch of them where you'll end up miscounting, or at least I hope you won't miscount. So just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals 11. There's a good reason why I do this way, where I have x bar twice and I have n twice. It's because this will be, all of this stuff will draw from over here. I don't have another way of saying that, but it just makes things work out to be a lot nicer. So this will equal whatever I have for x bar over there. N will equal whatever I put for n over here. New, well, that's going to equal whatever I have for n minus 1. S, that will equal whatever I have for s. Level of confidence, this one was 0.95 because there was none given. And we have alpha, and alpha is equal to 1 minus whatever my level of confidence is. Now this is a little bit of overkill, but whatever. Equals s. Doesn't matter. I didn't really need to put that in there again. This is a remnant from a previous spreadsheet that I did. So t sub alpha over 2 is equal to t dot inv dot 2t of whatever alpha is, comma, whatever my degrees of freedom are, but that's new. E, remember the calculation for that. It equals my t sub alpha over 2 times my s divided by the sqrt of whatever n is, and close my parenthesis there and press enter. So I get 69.9998. So that's why I put 70 down, because pretty much wherever I round this, it's going to end up being 70. So that equals, we take x bar minus e and equals x bar plus e. And I have this confidence interval, which, if I were to put that in words, that the students in the freshman class at this competitive university had an average somewhere between 1251.8 and 1391.8 with a 95% level of confidence.